Hello everybody. Now that you're familiar with placing the points in your scene with PCG, let's see what options do you have when spawning the actual meshes or blueprints in your level. Let's start with looking at the graph from the previous tutorial and see how we can improve some of the things. So the first thing I did is added the third person template into this game, so I can show you that there is no collision inside our PCG generated content. And this is one of the most often used options. So let's go into our PCG graph and see how we can change that. So let's disable the small objects in our placement and only work with our big objects, because it will be faster to show just on one of the static mesh spawners, and then I'll show you how you can easily control everything from just one place. The mesh entries that I have for this barrel spawning static mesh spawner are currently set up in 9 different array elements into my mesh selector for my static mesh spawners. So for each entry, if you open the descriptor, you have a bunch of options that you can set up. And one of these options is this collision preset, which is currently set to no collision. And the fastest way to set all of them when you have this setup with separate objects is to search for collision. And this will show you only the collision settings for all of them. So let's change them to block all. And this will generate a static collision channel for them. And all of the objects that we spawn will have this collision setup. So let's save this, regenerate the graph. And if I now click on the lit option right here and change the mode from the lit display of the player collision display, you can see for each object I have the collision spawned. This light green object is the collision object for each of my meshes. And for each of the different meshes, if you, let's remove the collision search criteria, and if you go into the static mesh that you're spawning, you can click on the eye icon and show the simple collision, and this green mesh which shows inside is your simple collision, which is used for the player collision right here. And if you don't have any collision, enabling the option into the PCG will not work. So you will need to generate a collision object from the collision menu. For example, for this kind of object, we can create a, let's say, capsule component, and this will be the collision for this object. Or you can use the option here for the convex decomposition of the object. You can set up how much objects you want and how much verticals each object will have. And when you click apply, it will generate a collision for you. But I'm happy with the collision that's coming by default from Quixel Megascans. So I will not edit it, just wanted to show you where you can check for your collision to be sure that it will work in your level. So if your object has collision and you set up your collision preset to block all, then when you hit play, you can go on top of the objects and you can see that collision is now working for all of our meshes. So this is how you can set up the collision, how you can preview it. And the problem part with this is that you need to change it for every single mesh separately. And the faster way to do this is if you find your objects, and these are the objects that I want to spawn. So I'll select all of them with Shift. I'll click Ctrl B to browse all the assets that are contained into my selection, and I'll just select the static meshes. So now I have all my static meshes shown right here that I want to spawn with this static mesh spawner. And instead of setting up all the settings into each separate entry that we have into our mesh entries, let's delete all of our mesh entries and change the type of the mesh selector type. Instead of PCG selector weighted, to PCG mesh selector by attribute. And this will set it up that we can forward the mesh that we want to spawn inside an attribute of our point. And let's search for an attribute called mesh. We currently don't have any attribute called mesh, so let's add an attribute and call it mesh. So add attribute, and the output target is mesh. Connect it here. And now the problem is that this attribute is not a soft object path. So let's change the type to soft object path. Let's save this. And now let's create a graph parameter for our graph and call it meshes. And the type will be static mesh object reference, and also it will be an array, not a single object. So now I can drag all of these 9 objects into my array element. So this will be the default value. Now I can get my meshes parameter by right click, search for meshes or the name that you've given your parameter, and I'll connect it here into the attribute value. So let's check what's happening right now. So here, for each point, it is giving it, sorry, I arranged them by the mesh. So let's arrange again by the index. So for each point, it's giving it a mesh from our list of meshes. Let's expand this window a bit, like this. And you can see that it's a pattern. So each mesh by its index here is assigned after the next one. So you can see that it starts with this shorter one, then this long one, then this 3 ones that each is a little bit longer address. And you can see this repeating. If you don't want this repeating pattern, you can actually, after this add attribute, use match and set attributes and connect these meshes to the match data. And now if I inspect this, but it's output here into the meshes attribute instead of the mesh attribute. So let's just change the name of our parameter to mesh. We will not add this attribute. We will directly call our array right here, our parameter. We'll rename it to mesh. And right now, this match and set attribute is picking a random mesh into each of our points. So if I expand this, you can see I don't have this repeating pattern anymore. It's just a random mesh for each of them. And I'm searching for this mesh attribute, finding it for each point and spawning each mesh. If I disable this, you can see I'm stopping the placement of our objects. So now I have a single descriptor. This template descriptor is controlling all of them. So if I change on a single place this collision to block all, let's save this and play our level. And let's actually first disable again the small spawners. So we don't have anything to distract us. So let's play again. Okay, so now I have my collision working for all the objects that I spawn. All the values of your descriptor in just a single place. So you have this template descriptor and it's the same for all objects that you place with this attribute name mesh. So this is a huge time saver. So you can add even more meshes here into your mesh array. So if you have 100 meshes, let's say, you will not need to change these attributes into every single type of mesh element. So let's continue with other examples of what values you can change. Into our static mesh spawner, one other common use for the properties of our static meshes is to set up the start cull distance and end cull distance in order to not be drawing these elements when you're too far away. For example, if I enable the smaller objects from before, so these smaller objects, if I go back, let's say right here, I'm not seeing that much of them. So let's select this static mesh spawner. Let's search for cull distance, and you can see that for each of them, you can set up the start cull distance and end cull distance. Let's set it up to 10,000 for the start and 15,000 for the end distance. And this means that after 100 meters, your objects will start to fade. And by the time that you go to 150 meters, all of them will disappear. The ones that are spawned from this static mesh spawner and from every instance of this different type of meshes. So because I'm setting all as the same value, you can do it the same like here with the merge attributes and have it working with match and set attributes, and then spawning by attribute, not selecting the mesh inside the static mesh spawner. But for the purposes of this demo, let's set it up right now like this. And if I go back, let's say this is probably about 100 meters. And if I zoom with the C key, and then I start to move back and forward, you can see that the small objects start to disappear when I go far enough back, and when I go closer and closer, they start to appear. But if you are looking from the original distance of our camera, and when I go back and when I go to the front, you cannot spot the change because the objects are too small. And this may be actually too big of a distance. Let's go 8,000 and 10,000 for each of them as a start and end distance, in order to save a little bit more resources. And of course, you can experiment with the values. Just make it that your object will disappear when they're not very crucial to the actual visual detail that they bring to your level. So you can save performance for other effects for your game. So right now, I think it's perfect. So I think this value is good, and I'll continue to the next example. So for every object, you can decide if you want to spawn a shadow or not. This is another thing that I'm usually controlling with my static mesh spawner. So let's search for shadow. And for some of the objects, for example, this chain right here doesn't really contribute that much with this shadow. And shadows are expensive to calculate. So let's go inside this static mesh spawner, which is spawning the chain, and find it. So it's this second entry right here. If I uncheck the cast shadow, you can see that this chain is no longer casting a shadow, but the overall scene quality doesn't really change that much. In that way, you can save some performance. So another thing that usually can be done in your static mesh spawner, and I'm doing quite often this, is if you have objects, for example, like this grass object I have right here, which are animated with world position offset. So this wind effect is done in my material with world position offset. And if I go far enough, for example, if I go right here, I don't really notice this effect that much. So it will be better to not calculate this effect if I'm far from this grass element. So let's start with first seeing what option we can use for fixing this. And this option will be this world position offset disable distance. And let's search for world position. And for each of the objects, I have this value to control where can I disable this distance. And in that case, only this grass element is using the world position offset animation. So that's why I'm only using it on this object. But let's say I set it to 100 units. So this means that if I'm a meter away from this grass, like I am right now, I will see the animation. And if I go more than a meter away, the animation will stop. And if it's a meter, of course, it's visible. But let's say you're doing this at 10 meters, which is right here, for example, or even still. Okay, so this is the mark. So here is 10 meters away, and here is the grass without zoom. I can zoom to show you it's not animating. But if I go a little bit closer, and if I zoom now, it's animating. Because the 10-meter mark, which I'm currently at 10 meters away, is marking where this animation is starting. And this can save you a ton of performance if you have a lot of grass or other foliage or flags or something else that's animated with world position offset. So I can even reduce it to 5 meters because I think it will be much better to save more performance if I'm not seeing this animation affected that much from the distance. So another thing that you can control with this static mesh spawner, you can control pretty much everything for the spawning of these objects, but some of the things are usually used more often. And one of these things, especially for the foliage that I showed right now, is that if you're using virtual shadow maps, if I go now to the view mode that we're seeing, instead of lit, let's use the virtual shadow maps and let's see the cached page. So right now, because I probably have set up already my object, so let's search for invalidation. Okay, I have it set up already for my grass, but the default value is out. And this means that everywhere where you have an object that's animated, this grass, this shadow of the grass, needs to be animated as well, and that's why it will invalidate your virtual shadow map in that area. And if I go further back, you can see that this area is very, very big, because the further it is, the virtual shadow map page is creating smaller resolution but bigger area for the shadows. And this is why a single grass blade right here can invalidate a huge area. And this is a very big problem, I believe, for the performance. So this is very much a consideration when you're spawning foliage to change this shadow cache invalidation to rigid. And this will make it that your shadow will not animate, but it's fine for this grass, I believe. If you want to have some animation on the shadow, you can enable, let's search for shadow again, and you can see that cast contact shadow is marked for every object. Let's remove for all of them and leave just the grass. And right now, if I search for my light, which is my directional light, let's go back to the lit mode, not the invalidation mode, the cached mode, and search for contact shadow for my directional light and put a value of 0.2, for example. You can see now we have a screen space shadow, which is 0.2 is a little bit too big, maybe 0.1. So we have a contact shadow for our grass, which is animated, and it's hiding this lack of animation on our other shadow, but it's saving a ton of performance. So this is another option that's very often changed into my static mesh spawners. And if you are using an animated object with world position offset, you should be changing this if you are using the virtual shadow maps, of course. Right now, I want to show you another example, and this is how you can work with these static mesh spawners in order to create more simplified version of the placement when you want to create, for example, collision for this kind of objects in your scene. So I have a graph set up right here. So let's open the graph that I have. This is my graph. So it's getting the spline from our level, and it's creating this fence, and it's creating these vertical posts. Let's show you all the parts of this graph. So it's creating this vertical post right here. It's creating horizontal posts, and it's creating this curved top part, which is covering the top part of all of our fence, because I want to show you some things for the spline mesh spawning later. So this is created right here with this spawn spline mesh. For example, if you want to add a collision to this mesh, because currently we don't have collision. So if I go to this fence, I can go right through this fence. But if I go to the static mesh spawners, and here is where I'm placing these vertical objects and these horizontal objects, I can go through each of them, and let's search for collision and add a block O preset to every element that I'm spawning. And if I save this now and go into my level, I will have collision working properly, and I cannot go through this fence. But the problem with this is if I go from lit to player collision, it will create a collision for each object, and this will make your scene much slower to run, because it will check for collision with hundreds of objects, and if this fence is longer and longer, it will be thousands or tens of thousands of objects. So instead of this, let's go back and remove the collision for the static mesh spawners. So no collision again. And instead of this, I'll spawn just simple cube with collision. So it will be this spawner which I created earlier. Yeah, this is the one. So the same points that I'm using to place the fence, I'm now using these points and scaling a simple cube. So I have this default static mesh cube from Unreal Engine spawning, but with these transform points into the beginning, I'm moving it into the place that I want, scaling it. It's scaled like 3.2, let's say, into the vertical direction in order to cover this top part. 4 into the X direction, so if it's set to 2, it's too little, so that's why I have 4, covering all the fences that I have right here. And in order to change these values for the scale separately, you need to uncheck this uniform scale, which by default is set to true, and click this walk icon to be unwalked in order to change every value separately. And in that way, you can create this kind of cube, and this cube is set up with the block all collision preset, and also it is set up as hidden in game. So search for hidden and click hidden in game. So if I look into my editor right now, if I go back to lit mode, I can see this object in my editor. But if I click to play the game, I can no longer see this object, but the actual collision is here. I cannot go through this fence. So right now it's working similarly to before. I cannot go through the fence, but I'm having a very few objects to calculate collision for, and the collision is just a box object and not the like 3 or 4 boxes that are needed to approximate this kind of shape that I have for these beams. So much simpler shape and much fewer shapes. And this is done by knowing how you can use the static mesh spawners into your PCG graph with the different settings in order to achieve this better result. So the other thing that I wanted to show you is how you can spawn blueprints. So I have a blueprint, which is this tire with a collision box, and this collision box is set up that if I go through this collision box, I'm picking up the tire and it's disappearing from the level. So let's say I'll go back here into my graph that I had before, and I'm enabling all the spawning of the objects that I have before. So here into this static mesh spawner right here, I'm spawning all these small objects and also this tire. So let's say I don't want to spawn this tire. So let's go here into my mesh entries, find the tire, which is this first object, and I'll actually remove the static mesh that is spawned here. And why I will do it this way? So let's save this and select the attribute. So I still have the entry for placing a static mesh, but this static mesh entry doesn't contain any static mesh. But the great thing that it will do for you is it will create the points, but it will leave here the reference to the static mesh at the end of your values empty. So what you can do right now is go here and create a point filter. So this point filter will check if our last used value, which is this, or let's type none, our value called none is the default name created from the static mesh spawner, or you can change it here, out attribute name, let's call it SM for static mesh. So here let's check for the SM value, let's check for constant threshold, and if it's equal to a string, and the string is empty string. So let's save this. So inside this filter, let's click the A key to inspect this. Inside this filter you will have all the placement of your points which contain no static mesh reference right here. If I change the inside filter to the outside filter, it will contain all that have a value different from an empty string. So let's go back to the inside filter and connect this to a spawn actor node. So drag out of this, spawn actor, and this actor, for the template actor class, connect the blueprint that you created. And this will place this blueprint on all of the places that we previously had the tire. So let's save this. Let's go back and play our level. So right now if I go next to each tire, you can see that my blueprint is working. I'm picking up all the tires, everything is fine, and I can pick all the tires from this junkyard. So again, this is done by knowing how you can control the values of your static mesh spawners and how to use them in order to create the gameplay features that you want. So another thing that I want to show you is when adding collision to spline meshes. So let's go back into our example fence right here. Let's disable the static mesh spawner for our cubes with the collision, and let's go to our spline mesh example right here. So this spawn spline mesh is spawning this curved beam at the top. So it's creating a spline. Let's show the points of this spline. So this is the spline, and we are using this spline. These are the control points of the spline. We are using it to spawn a spline mesh, which means that it will create a beam between each of these points and it will curve it in order to match the spline between these points. So this spawn spline mesh is connected to the beam, to this beam, and this beam has collision set up by the Quixel team. Let's show the collision. Click on the eye icon and simple collision. So it has this collision, or actually I believe I made this collision. So these are 3 boxes which approximate the shape of this beam, but they're stretching from one side to the other is just a single box for each of these 3 parts of this beam. So the vertical and the 2 horizontal ones. So a single box for each of them. And let me show you how this looks right now. If we go into our graph, let's select our PCG graph. Let's select our spawn spline mesh and add a block O collision. And now let's visualize our collision with the player collision mode right here. So because each beam is just a single box, it cannot curve your collision like it's doing for the meshes that you spawn. So in order to fix this issue, you can create a smaller collision boxes. So for example, if I go here and remove the collision of this object by clicking the collision menu, remove collision, and then add a box collision for it, then scale this box, for example, to about 1/3 of the size of this beam, then I'll click and drag from this move gizmo. And because right now we have split this collision to 3 separate boxes instead of just one long box, it can do a much better job of placing this collision and curving the collision to match this curve. So again, if your collision is just a single long box, you can see it cannot curve it. It's just a straight line. But if it's smaller boxes, it doesn't have problem of curving them. It moves them a little bit to match the curvature. So this is how you can control the spline mesh collision. So these are the most important options that you can find for the spawners in the PCG framework. I hope you like this tutorial. If you do, please subscribe for the channel, like the video, and if you join the channel into the higher levels, you can watch the tutorials earlier than anybody else and ask your questions and get your answers earlier. This will support my channel and help me continue to do this. And guys, I'll see you in the next tutorial. Bye.